Okay, this is some work I did about 9 months ago, so it may have been superseded. Basically, I wanted to protect some of my code that I've written for the desktop from being decompiled. At the time I actually ported the code from .NET Framework to .NET Core, and then ran it through the compile to native tool that Microsoft produced, which was a beta at the time. Which meant to say that eventually I went to bed. The next morning I got up and found out that the tool had crashed, and that left me a bit of a quandary. So basically this is all about decompilation and Pimp, which is a bridge pattern in design patterns, and hope you all like C++. So here's a C# binary that's been decompiled in JetBrains.peak. So that's the sort of thing that happens with standard code, and it even decompiles your comments, basically. So it's quite useful as a pretty printer. If somebody doesn't bother to indent the code, you actually run it through this, and then suddenly your code looks beautiful. So it's C# is interesting for deploying to the desktop if you want to actually make sure that people can't actually decompile your code and rip off your IP, basically. So there are obfuscators, but I've never actually had much luck with obfuscators. And in the age of refactoring tools, you can just do renames and such like. So to get around this, I recoded in C++. So this is variously called Managed C++, C++ CLI, C++ CLR. Microsoft keep on changing the name they call it. So on the left there's a header file, on the right is the actual source file. So the managed pointers are signified by using a caret rather than asterisk. So you see there, so that's basically the .NET string class, which is being accessed from C++. So you see we designate a managed class using the ref keyword, and we're using Pimp, so private implementation. So whenever we create a new instance of our managed class, we create a new instance of our unmanaged class, basically. Which so that's the private implementation. So basically there's no ref in front of the class name. We actually store managed objects using special templates, and we can call all our standard .NET functions using standard calls. Obviously we got double colon rather than dot for the qualifier. So once we do that, we can compile it all up and see what happens when we run it again through the decompiler. So that's the public implementation decompiled. So it's all pretty standard, so it looks pretty much like the code we wrote, basically. You notice it decompiles as actually C++ rather than C# in .peak. And this is the private implementation decompiled, which basically says it can't actually do anything with it. So your code is then absolutely protected from decompilation, I hope, or at least through straightforward using JetBrains.peak and similar tools, which are all based on the same library. So that should actually ensure that you can't actually access the IP, basically. And one thing to be aware of is the finalizer, which is a managed C++ special function. So this is a bit like the destructor, but it's only called in the garbage collector, so which is running a separate thread. So that means to say that if you try and deallocate unmanaged memory using the finalizer, then you get a crash, basically. So I discovered that when I was actually trying to run my unit test suite, and it would only get through about 3 unit tests before it actually crashed, and then you could actually start the next set of unit tests, which is a bit tiresome having to do all that manually rather than just hit a button and run them all at once. And I talked too quickly, didn't I? So yeah, so that's how you can basically go and create lots and lots of technical debt and lots of extra work to actually convert all your C# classes into C++ classes, or two C++ classes I should say, just to make sure that people can't actually get the guts of your code, basically. So, any questions?
How does it compare to using commercial obfuscators that you can buy?
I never got that far. I did actually try and evaluate obfuscators, but basically if it just says it's obfuscating, it's basically you can still decompile and get to the source code, and obviously just do use some refactoring tools to rename your methods and such and deobfuscate that way. It may be a bit of a pain, but you can still get access to everything. So the other thing, of course, is you can I saw was that you could actually encrypt your binaries and such, but I never quite worked out how that worked. So it seemed to be much more straightforward to actually write a little script to do some translation from C# to C++ to create all these classes. I say create, but obviously it was completely bug-ridden. So there were lots of little bits to tidy up, and had the test suite to actually tell me if my tests passed at that point. So yeah, it's definitely a potential solution, but I'd rather actually the compile to native have worked, because I did all the work in importing from .NET Framework to .NET Core, then found out that the actual compile to native just crashed. Just a little bit of a pain. So. Thank you.